This is some video help for mathematics review. This is page 3 of homework number 1. There's 8 questions on this page, but I'm not going to work these problems, but I'm going to work problems very similar to these. So for example, on question number 1, it asks you to put an equation in y-intercept form, and this is what this means right here, or slope-intercept form rather. Here's the slope, there's the y-intercept. So if you have an equation that looks like this, I just made one up, you want to move everything that's not related to y on one side of the equation, so you just get 7y equals negative 7x minus 21. Divide both sides by 7 and you get negative 1x minus 3. So you see that the y-intercept is minus 3 and the slope is minus 1. That means that if you were to graph this, what that means is that it's going to intersect the y-axis at negative 3. This is the y-axis, that's the x-axis, and the slope, it goes over 1 and down 1. That's what the minus sign means. So that's the rise over run. This is what that line would look like. I can erase that reference line right there. So here is the line that we're talking about. There's the equation of the line. On question number 2, it gives you a point out in space, not this point, but another one. I'm just going to make up a case here where I have a straight line like that. In this case, it would be a rise of 1 and a run of 1. So that means that I've just randomly selected the slope to be 1. So if you're looking to put this in y-intercept form, you first start off with kind of more or less a point-point slope kind of approach. And this is the point that we've labeled here. This is one of the points we know that the line goes through. So we can use that over here. We can say that y minus the y point, which is 1, the slope is known to be 1, the x value is given to be 2, and all we got to do now is make it look like it's in y-intercept form. And so we say that it's y minus 1 equals x minus 2, just to kind of give it a different look, I suppose. And then you just add 1 to both sides of the equation. And the slope is going to be 1, the y-intercept is going to be minus 1. When you're dealing with a question like problem number 3 and you have two variables that are multiplied times each other and each of those has a power, all you do there is just add up the powers. So that would be to the 12th. In a problem that looks like this, which is like number 4, it's asking you to factor them out. So it's more or less kind of a guessing game. You have x like this, and you can see that if you kind of look for a pattern, it's got to have a 2 and maybe a 10 right there. It looks like that might be the case, except when I multiply this times this, I get a positive 20, and I got a minus sign right there. And then I look at the cross terms here, I got a minus 8, so it looks like this one has to be minus, that one has to be plus. If you multiply this out, you'll find out that you get this equation. On question number 5, it asks you to use the quadratic formula, and here that is. And what the quadratic formula does is it gives you two answers to an equation that looks like this. Here are the coefficients a, b, and c. So a is on the squared term, b is on the linear term, and c is the constant. So there's two solutions to this equation. This finds both of them with their plus or minus. The surprising thing about question number 5 is that there may be only one solution, if I remember correctly. So it might be that this term is 0. So don't be surprised if you get something like that. But in general, the quadratic formula allows you to find answers to that equation I showed you a moment ago. Number 6. What we're looking at here is an equation with a log term in it, and you're asked to solve for something on this side. I think it was y in the other case. I just used x here. Just like you have a sine and an inverse sine, in the same way the logarithm works kind of like that. The inverse of a log is actually 10 raised to that power. So if you take 10 raised to the 4th power and you do the same thing to the other side, I mean, that's really what mathematics is all about, doing the same thing to both sides of an equation. You get this. And so what I meant by this being the inverse of a log base 10 is that over here you get 10 to the 4th, and over here you just get the argument that's inside of that, which is x squared. You can finish this out and you see that x is equal to the square root of 10 to the 4th. Now please remember that I'm just working example problems. I'm not working the homework for you, but I do hope that this helps you out in finding these solutions. On homework number 7, they're asking you what it means to solve for a particular value of a function. I just had picked 0. I think that was the example they used also. Different equation, but all it means is that you take this value and you put it into the equation, so you get 12 times 0 plus 17, and so the answer to that would just be 17. Alright, so if you did something else, like if you plugged in a value of 1, it's basically saying 12 times 1 plus 17 equals 29. And you can continue that kind of process. If this was a 2, you'd put a 2 there and get 24, etc. And on question number 8, just use the solve and substitute method that we used in homework 0, the warm-up. Hope this helps.